What is the Internet? Internet may be defined as a communication service which is based on communication protocols. Communication protocols, in turn, are nothing but a set of rules that allow us to format, to send, and to receive an information. Here we see an example between a host and a server which send information over the Internet as a communication service. In fact, a network provides a communication service to applications which might run on hosts, on servers, to transport such information between remote processes. The transport service may be offered by the network applications and can be different types, so it can be different depending on the quality of service. When referring to short messages, it can be transported in an unreliable mode, meaning that there are signals to be sent which do not need to be acknowledged that they have been received, or we might deal with long sequences of bytes, in which case we need a reliable communication. Applications, in fact, ask for the most appropriate service, depending on the interfaces, on the programming interfaces that they use, such as based on the application programming interfaces that they use. In fact, networks are quite complex. The Internet is complex because it's composed of many pieces, such as hosts, routers, links of the different types of media, wireless, wired, different applications, different protocols, different hardware, and different software. So the question that we pose is that in case there is a possibility, if there is a hope of organizing such a network structure in an easier way to understand. In fact, we start from an analogy of organizing air travel. In fact, to do so, we need to follow a series of steps. Such steps include first purchasing a ticket, then we need to do the baggage check, we need to arrive to the gate, then the plane takes off and the plane needs to go towards the destination. Once we arrive in the destination, then there is the landing in the runway. We need to arrive to the proper gate to collect the baggage, and this way we have arrived in our destination. This analogy, in fact, can be also applied to the Internet. The main idea here is that we are using a layering analogy, where each layer implements a service. And in fact, when we deal with complex systems such as the Internet, it's very important that such a complex structure allows to have a clear relationship, or must have a clear relationship between the different pieces of such a complex system. In fact, doing such a modularization might ease maintenance and allows us to update the system as we go. However, it might have some burden because we might need to duplicate the same function in different layers, and it might be that the protocol layer, which operates only in the given layer, needs to have information from the other layers with which it coordinates. In fact, going back to the Internet, the layering system which has been adopted is referred to as TCP/IP model. It defines 5 layers as listed here. L1 is the physical layer, data link layer, network layer, transport layer, and the application layer. All of these layers must be cohesive and communicate between one another in order to ensure a smooth operation. In fact, the application layer supports network applications such as the one that are mentioned here, the DNS, HTTP, and so on. The transport layer provides service for host-to-host data transfer, and its most known protocols are the TCP and UDP. The network layer provides routing of information units between different network equipment, and it does so through its corresponding protocols, such as IP, OSPF, and so on. The data link layer transfers these information units between neighboring network devices, and it does so through protocols such as Ethernet, point-to-point, and Wi-Fi, and so on. In turn, the physical layer allows to transfer physically the bits on a wired or on a wireless communication channel. In fact, what is important to understand is that going from one layer to another, the payload, which is the message that we need to transmit, is added a corresponding header which corresponds to the layer. In this case, we have the payload transmitted from layer 5. When such message is transmitted from layer 5 to layer 4, we have an additional header corresponding to layer 4, which is added. In a similar fashion, we have a header at layer 3, which is added, a header at layer 2, and a header at layer 1. In the same way, when the data has been received on the receiving end, we have the opposite function. We have the decapsulation. So in this case, going from layer 1 to layer 2, then the header of layer 1 is removed. Going from layer 2 to layer 3, the header of layer 2 is removed, and so on, such a way that when we arrive at layer 5, we have only the header pertaining to layer 5 and the actual message that we want to transmit. The messages which are sent in a different layer, we refer to them with different names. So the one on the uppermost layer are referred to as messages. The information which is exchanged on layer 4 is referred to as segments. The information at layer 3 is referred to as packets. The information at layer 2 is referred to as frames, whereas the information at layer 1 is referred to as bits. Each of these layers has its corresponding protocols, which are defined depending on the application that they serve.